Chapter 17.3 Decision Making Under Uncertainty. Now that we have constructed the decision table for Mellon's Bakery in the previous section, we are now ready to explore a variety of methods to help the owners decide how many buns to bake on a given day. The first technique that we will look at is known as decision making under uncertainty, which is used when you do not have any information about the probability of the various states of nature occurring. Under this condition, the following approaches can be used. The Maximax criterion. Using the Maximax criterion, you simply find the highest payoff in the decision table and select the corresponding alternative. Table 17.4 demonstrates this decision-making technique. Using the Maximax criterion, Mellon should choose to bake 60 dozen buns for the day. This choice provides the opportunity to make the maximum profit in the decision table, which is $540. The Maximax criterion is the most optimistic method, as well as the one with the highest level of risk. Baking 60 dozen buns can result in the highest profit, $540, but can also result in the highest loss, $100. The maximum criterion. Using the maximum criterion, you identify the worst payoff for each alternative and then choose the alternative that is the best of the worst. Table 17.5 demonstrates this decision-making technique. Using the maximum criterion, Mellon should choose to bake 20 dozen buns for the day because this alternative will result in the largest payoff in the worst column in Table 17.5, or $180. The maximum criterion is described as the most pessimistic method, but the one with the lowest level of risk. In this example, baking 20 dozen buns ensure Mellon that the worst the daily profit will be is $180. The equally likely criterion. Using the equally likely criterion, you choose the alternative with the highest average payoff across all states of nature. This technique assumes that the likelihood of each state of nature occurring is the same. The calculations are as follows. Table 17.6 summarizes the result using the equally likely criterion. Using the equally likely criterion, Mellon should choose to bake 40 dozen buns for the day because this alternative provides the highest average payoff in Table 17.6, which is $253.33. If all of the states of nature are equally likely to occur, the level of risk associated with the equally likely criterion lies somewhere between the risk associated with the Maximax and maximum approaches. The Minimax regret criterion. You should use the Minimax regret criterion if your goal is to minimize the amount of regret you would experience, or in monetary terms, if a wrong choice is made. Think about a time when you made a decision only to regret your choice later. For me, it was eating the last sticky bun. The goal of Minimax Regret is to choose an alternative that minimizes the feeling of regret. We will need two tables to describe this approach. First, we will identify the best payoff for each state of nature. These payoffs are highlighted in Table 17.7. Second, we subtract the actual payoff in each column for the best payoff in that column. The difference is the regret the owner of melons would feel by making the wrong choice. For example, if day's demand for bun were 20 dozen and melon had baked 40 dozen, the firm would have made a profit of $40. Had the firm only baked 20 dozen, or the best alternative for a demand of 20 dozen, it would have earned $180 in profit. The difference between 180 and 40 represent the regret for making too many bun, which is $140. Table 17.8 displays each of these calculations. Third, we identify the maximum regret for each alternative, which is shown in the last column in Table 17.8. For example, melons decides to bake 20 dozen bun. Its regret will be $0, $180, and $360, depending on the eventual demand level. The maximum regret for this alternative is therefore $360. We do the same for the other two alternatives. Finally, we choose the alternative with the smallest maximum regret, which is highlighted in Table 17.8. If melons chooses to bake 40 dozen bun, the maximum regret it will experience is $180. This regret represents the smallest maximum regret for all of the alternatives. Therefore, if melon uses the maximax regret criterion, it will bake 40 dozen bun for the day. The Hurwitz criterion. Our last but not the least decision-making approach using decision-making under uncertainty is the Hurwitz criterion, which allows the decision maker to choose the level of risk he or she wants to assume. On the risk scale, the maximax criterion lies on one side, or high risk, and the maximin criterion lies on the other, or low risk. The Hurwitz approach uses a parameter alpha, which is known as the index of optimism, to choose a level of risk as shown in equation 17.1. This sounds like a very happy parameter. Our first step is to choose a value for alpha between 0 and 1. If the decision maker is very optimistic about the future state of nature, he or she will be inclined to make a more risky decision. The higher the value of alpha, the more risky the final decision. When alpha equal to 1, the Hurwitz criterion matches the result of maximax choice. If the decision maker is very pessimistic about the future state of nature, he or she will be inclined to make a less risky decision. When alpha equal to 0, the Hurwitz criterion matches the result of the Maximin choice. Suppose the owners of melon are comfortable taking on a fair amount of risk with their decision, and therefore choose alpha equal to 0.7. For the harvest criterion, this value of alpha will provide them with the opportunity for a greater profit, but will also expose them to the possibility of a larger loss. This value of would be a good choice for decision makers who feel confident that a disappointing state of nature will not have serious consequences to the financial health of the organization. For each alternative, we select the highest and the lowest payoff from the decision table shown in table 17.3. This day's profit are shown in table 17.9. Using equation 17.1, we multiply the highest payoff time and the lowest payoff time, or alpha 1 minus alpha. These two results are then added together for each alternative. These calculations are as follows. Bake 20 dozen equal to $180, bake 40 dozen equal to $264, and bake 60 dozen equal to $348. We then choose alternative with the highest profit, which is to bake 60 dozen bun. As you can see, when alpha is closer to 1, more weight is placed on the highest payoff, resulting in a decision that is more optimistic about the future. When alpha is closer to 0, more weight is placed on the lowest payoff, resulting in a decision that is less optimistic about the future. The benefit of the Hurwitz criterion is that it allows the user to choose a more precise level of risk with the value of when compared to the Maximin and equally likely criterion. That wraps us all of the ways we can make decisions under uncertainty when we have no information about the likelihood of the state of nature occurring. Table 17.10 summarizes our finding. A great question my students often ask is how you choose a criterion. Notice that the alternative melon would choose varies depending upon what its criterion is. Risk is often the basis for decision making in the business world. If the economy was strong, sales were great, and the owner of melons had a lot of cash in bank, the company might choose the Maximin criterion. If the economy was weakening, sales were dropping off, and money was tight for melons, the company would probably choose a less risky criterion. Baking 60 dozen bun every day in this situation might not be such a good idea. Thank you.